side. All right, angular velocity. Angular velocity is basically how fast something travels in a circle. Okay? How fast something travels in a circle. Okay, for you gearheads, I don't know how many gearheads we have in here, but an engine, okay? An engine runs, and inside of an engine, there's a crankshaft, right? And it makes the pistons go up and down and so on. But the crankshaft travels in a circle. And how do we measure the speed of a crankshaft in an engine? RPM. Stands for revolutions per minute. Rotations per minute was close. Revolutions per minute. Okay. How far it travels in a minute. Now, angular velocity doesn't go on revolutions per minute. It goes on how far you travel in radians. So for us, angular velocity is W equals the angle, the number of radians it travels over a specific number of time. So angular velocity is kind of a W thing. This is radians, and this is time. So we might speak of angular velocity as 32 radians per second. Okay, this is an example of angular velocity. Okay, so a number of radians traveled in a second. Now, let's say I have a vehicle that's running at 2,400 revolutions per minute. What's revolutions per minute? With RPMs, okay? So it's running at 2,400 RPM, okay? How many radians per second is that? So we want to transfer this into radians per second. Okay, to do this, we're going to use unit conversion ratios. Where do we use unit conversion ratios? Other places in high school? Chemistry. Back with weebs when some of you were weeb. Wait, how many? Most of you, some of you are seniors. You had weebs. Okay. Yeah, a vast majority of you are seniors. Okay, Jackson, Lucas are juniors, and Lucas is a junior. You're a junior or senior, Mr. Olson? Junior. You're a junior. Dion's a junior. Yeah, we got juniors kind of back over there and right there. Renee? Yeah, Renee is a junior. We got a sophomore. Well, yeah, we got a sophomore back there. We don't worry about the sophomores. Okay. But yeah, chemistry, physical science with Swenson. Uniconversion ratios in there. Okay. Uniconversion ratios. If I want to end up with radians, I have revolutions. A revolution is how far? If I make one revolution, how far did I go around that circle? All the way, how many times? One time around the circle. Well, how far is one revolution around the circle in radians? 2 pi. So I know if I want to end up with radians on the top, I got to put radians up here. 2 pi radians. I know there are 2 pi radians in one revolution. Okay, revolutions and revolutions are going to cancel. Now I have radians per minute. I want my answer in radians per second. Do I know how many seconds are in a minute? I better. In 1 minute. Why did I put minutes on the top? Why didn't I put seconds on the top? Because we want to cancel out minutes, and seconds should end up on the bottom anyway. So 1 minute over 60 seconds. Okay. So if we do the math, I know 2400 goes into 60 40 times. So 40 times 2 pi is 80 pi radians per second. 80 pi radians per second. Okay? So that's a unit conversion ratio working with angular velocity. Okay. So let's say we have a windmill. That has blades 70 feet long. Those big wind towers, you know, those big blades. The blades are 70 feet long. If a blade travels at 40 revolutions per minute, what is the angular velocity in radians per minute? Okay, what is the angular velocity in radians per minute? All right, so let's figure this out. I have revolutions per minute, 40 revolutions over 1 minute. So that blade goes around that windmill 40 times in 1 minute. So it's a windy day. Okay, the wind is blowing pretty hard for that thing to go around that many times. How do I change that into radians per minute? What do you multiply by? 2 pi radians over 1 revolution. Do I have to change anything else? No. What does 70 have to do with it? Nothing with this part of the problem. Okay, so the revolutions cancel, and we get 80 pi radians per minute. Okay, we'll come back to this problem again in just a little bit. Okay, that's angular velocity. Now, that's basically all you need to know except for the very last problem on today's assignment. But I need to also cover right now Friday's assignment. Okay, so I need to cover Friday's assignment. So those of you who are here on Friday have something to do, you know, because I don't want you just to sit here and no, you'll have plenty of study halls, I think, on Friday.
You could have been one of them.
I could have, but I'm not. Okay, but you can possibly get most of this stuff done between today and tomorrow's study hall anyway. So. Oh, that's right. Well, you can get it done sometime. All right. Linear velocity. is how fast something would travel in, what's the base word of linear? Line. So in a straight line. So if a tire spins at 60 revolutions per minute and it's 28 inches in diameter, how fast does it travel down the road? In miles per hour. Okay. If a tire spins at 60 revolutions per minute, it's going pretty slow. Okay. And it has a 28-inch diameter. How fast does it go down in the road in miles per hour? Now, linear velocity, it is marked in terms of, and I got to look this up because I don't want to screw you up when it comes to this. Okay. Linear velocity is equal to arc length over time, which equals S over T. Okay? Or you take the angular velocity times the radius. So if you have angular velocity already, you just take it times the radius. If you don't, you take the arc length divided by time. Okay? So these two formulas allow us to figure out what linear velocity is. Now, most of the time, we go with this one. Okay, most of the time we go with this one. But know that it also works with that. Okay, so let's deal with this tire problem. We have 60 revolutions per minute. And I want to change that into angular velocity. How do we change things into angular velocity when it's in revolutions per minute? Multiply by 2 pi. There's 2 pi radians in 1 revolution. And now all of a sudden, I have radians per minute. We have angular velocity. What did I say to take angular velocity by? The radius. I have a 28-inch diameter tire. If it's a 28-inch diameter tire, what's the radius? 14 inches. So I'm going to take this times 14 inches. 14 inches per what? Well, 14 inches is the radius. Okay? So radians will cancel with the radius. Radians and radius will cancel with each other. So now I have 14 inches per minute. If I want to get into miles per hour, then I just do simple unit conversion ratios until I get there. Okay? Inches. Does everybody know how many inches are there in a mile? No, I didn't think so. But does anybody know how many feet are in a mile? Yeah, absolutely. I was waiting for Mr. Olson to shout out a correct answer because that's what he does. That's his job in here. You need to memorize the fact that there are 5,280 feet in 1 mile. Oop, I need miles on the top. Come on, Mr. Bierschbach. In 1 mile, there's 5,280 feet. Oh no, nothing canceled. So how do I get things to cancel? I have inches on the top, feet on the bottom. I know that there are 12 inches in 1 foot. So feet and feet cancel, inches and inches cancel, and now I have miles per minute. What do I want my final answer to be in? Miles per hour. So I want hours on the bottom. So in 1 hour, there are how many minutes? 60. And this, you need a calculadora, por favor. 60 times 2 times pi, and hit the pi button, times 14, times 60, hit equals, divided by 5280, hit equals, divided by 12, hit equals. So how fast is that vehicle moving down the road? And it's going fairly slow. A half of a mile per hour?
No, 5.
5 miles per hour?
4.9.
Yeah, well, let's just say 5 miles per hour. Okay. That is linear velocity. Okay. It all depends upon the radius and the angular velocity. Okay. Do you want one more example? No. Because you can get examples, and this would give you a half hour to work on assignments, and I'm going to assign them both out today. I'm going to put both of them out there today, and then you have however long that you want to work on them. So those of you in class on Friday will have basically time to work on section 1.3b. Those of you gone, you could maybe work on it on the bus, on the people mover. How many volleyball players? We got Megan in here and Raina. Okay. So let me assign those out, and you should be good to go. All right. Just a second.